risk analytics in financial services. Now, why and how does that matter? Let's just cover that for 1 second. I was with London Stock Exchange Group. One of our assets was LCH, London Clearing House. LCH clears approximately $1.5 quadrillion a year, okay? Let that sink in, $1,500 trillion. The way that clearing occurs is after the trade happens, the post-trade process where there are two parties in a trade, the post-trade process says that once that trade has been cleared, LCH, the clearinghouse, ends up being at the heart of that trade. And if one of the counterparties was to go down before that trade has completed, LCH is actually responsible for that, okay? So when you're talking about $1.5 quadrillion, you can imagine the types of impact even a small fraction of that trade not going through would have on the global economy. And these are the types of issues we dealt with in the 2008 financial crisis. So what we're showing you, and by the way, this is all real, so this is not a made-up demo, although we have a backup video just in case things blow up. But so what you're going to see is all very real. This is running inside NVIDIA's labs. They've given us access to a bunch of GPUs. And what we're able to show is that normally speaking, these risk processes end up happening end of day, which means that if there are events that are happening during the day, the clearinghouse or the broker-dealer, whoever is behind the trade, is responsible for that intraday movement. And if there is a large intraday movement that occurs, you can have a very massive impact on your books. So risk desks are really interested in making sure that these types of trades clear and they're not carrying risk on their books. So end of day processing doesn't work. We have shown that for Liberation Day, which was in April of last year when we announced tariffs, just on that day, there was movement of approximately 50+% up and down during the day. And if you were not catching that movement, that ended up costing many of the broker-dealers like JP Morgan Chase and others massive amounts in fines, like $250 million in fines, because the regulator wants to know that this is happening correctly. So what you're seeing in this demo is we're bringing in market data, and we're bringing in market data from different sources. This is Polygon. You may have different types of information inside your enterprise data lake, in Hadoop HDFS clusters, or wherever that information may be sitting. And you may be bringing in unstructured data, which we're bringing in from this project. It's a government project called GDELT that brings in unstructured data about any types of information that you're looking for. You may be interested in NVIDIA stock. You may be interested in SPY. All of that unstructured information, as well as structured information, meaning market data, is flowing in through message queues and coming into Infinia. So what we're doing is we're putting that information inside a single data lake. This is extremely important because if your information is scattered all over the place, you have no way of knowing exactly where to go and you may have to recalculate that information. You don't want to waste your GPU time or CPU time on those recalculations. So making sure that that information lands in raw as well as processed forms within your enterprise data lake is absolutely critical. And this is where our product Infinia plays a role. Once that lands within your enterprise data lake, what we're doing is we are leveraging NVIDIA's NeMo curation capabilities, which goes out and does chunking on the unstructured data that's coming in and puts that information into a vector database so that you can recall that information very, very quickly instead of needing to wait for hours and hours to query different types of queries, questions that you may have for these LLMs. And we are, at that point, we've incorporated NVIDIA's Nemotron, which is, we're using a 49 billion llama model to set up a LLM to be able to query that information, to ask the markets what is happening in the market right now, how this may impact my portfolio. At the same time, what we're doing is we're pushing that information through a risk calculator, such as Monte Carlo simulation, or you may be using any type of an ISV like Calypso and others to be able to calculate those risks. And that lands in a financial terminal. This financial terminal is very similar to what a risk desk may be seeing, generally speaking, where they're bringing in information on particular stocks. They have different types of unstructured data coming in, which is telling them what is happening with that particular stock. And while you can run different